Hi, so in this video we're going to learn more about molecular effusion. So effusion is a process by which a gas escapes from a very small hole. Okay, so just with that concept in mind, let's take a look at the given problem here. So essentially, I'll let you read it. I assume that you read it already, so let's go ahead and solve it. So we have an astronaut that it's doing his thing, going for a spacewalk, and unfortunately a tiny piece of space dust punctures her suit. So we're asked to find the acceleration of this tiny hole is provoking. So let's see, if we think about this problem in terms of pressure, right? We know that pressure it's equals to force over area, where force it's equals to mass times acceleration. Okay, and if we substitute this for force here, so we're gonna have pressure it's equals to mass times acceleration over area. And we can either solve for acceleration right here, so let's go ahead and do that. So we solve for acceleration, so we're gonna have acceleration it's equals to pressure times area over mass. Now we can calculate the area of the hole by dividing the 1 micrometer per 2, assuming that this is the diameter. So we have 1 times 10 to the negative 6 meters. We divided by 2, right? And let's see what is 1 second e to negative 6 divided by 2. So we get about 5 times 10 to the negative 7 meters. So we can use this radius. So radius is equal to this. So the area will be pi r squared, where pi is 3.14, so and so, and this is 5 times 10 to negative 7 meters squared. So let's square this, then we multiply by pi, so we get about our area, it's roughly 7.8, 5 times 10 to the negative 13 meters squared. Okay, so we found our area. Now we can find, actually we're given the rest of the things. So we're given that the pressure it's 1 atm. So pressure it's equals 1 atm, and we know that 1 atm it's also we can turn those into pascals. So it's about, pressure can be expressed as 325 pascals. And if you guys remember that pascals would be Pascal, I'll just do it right here. Pascal it's equals to the unit is kilograms per meter times second square. All right, and if you look back, we are given that the mass is 150 kilograms. Okay, so basically we just plug and chug at this point. So we're gonna have that a acceleration it's equals to, just do this simplification, 325 kilograms inverse meters times inverse second square times what was the area, which was 7.85 times 10 to negative 13 square. This is over the mass, which is 150 kilograms. And we see that our units cancel out nicely. Your kilograms cancel with this kilograms. The inverse meters cancel with one of these meters. So essentially we have units of meters per second square, which is acceleration. So I think at this point is the easy thing to do. Just plug in your values. Let me see what I get. Times 7.85 second e to negative 13 by about 150, which is about 5.30 times 10 to the negative 10 meters per second square. So even though there was a very small hole, those are very small change in pressure, escaping the oxygen, you can see that it's not that much of a deal. So the acceleration is very, very, very small. So what we did here, I think the most challenging thing was first to know the relationship between force and mass and acceleration. And I think once you know that, then it's very straightforward. We also needed to find the area of a circle, and to know that 1 atm can be expressed at pascals. But I think other than that, I think this is a fairly straightforward example. So if you have any questions, please let me know in the comments below.